Hi there, it's Mr. Rops.
And this is Mr. Song.
Okay, we're going to do some more integration. And when we see this scenario here, you have to recognize that, it's a little tricky, this one. The bottom of that fraction, the denominator, if I see that, it looks, there's a relationship between the denominator and the numerator. You see what the relationship is there, Mr. Song?
I think the numerator is the derivative of the denominator.
Sweet. Okay, so that means we make the denominator our u value for this U substitution technique. So when you see an integral with where the derivative is a function somewhere inside, then we can use that. So u is going to be 3x to the fourth minus x cubed. And we take the derivative of u with respect to x.
And you get the numerator, 12x cubed minus 3x squared.
All right, and that's quite convenient. That's exactly the numerator. So then we know that du is just multiply both sides by dx. And the whole purpose of u substitution is to make our integral easier.
Accidentally put du there. It's actually dx.
All right. And so we're going to try and make this integral easier, more recognizable. So let's do some substituting. Okay, I know that the denominator is exactly u. Okay, the denominator is u, and the numerator in dx is exactly du. So I can make it 1 over u times du, because the numerator is equal to du. Well, that's an integral that I know quite well. If you look at your formula booklet as well, you'll see it, and it's ln x, or ln u, rather.
Do you put the absolute value sign there?
Technically it is, but we don't worry about that in SL. We always put a condition to make sure it's positive.
Okay.
Plus c. And then the very last thing we do is we replace u back in, or we put the x's back in, into there, and for that u, and we get, the final is ln 3x to the fourth minus x cubed plus c. Okay, and that's the key. You integrate with something easier, and then at the very end, you put the x's back in.